Hello, people. What's going on? We're just waiting. I should have maybe updated the game before starting the stream, but I didn't, so now we're waiting for it to update. Oh, whoops, category. Wrong category. We are here to do science and technology. Yeah, look how much faster it would be to use Git with all these large files. Git is great at transferring a gigabyte of binary data. We all know that. Yeah, they kind of need to bring back the programming category. Although, honestly, there's not that many people who do programming on Twitch. So maybe what needs to happen is people need to get off their app. Okay, here's the thing. Here's the thing. There's all these people in the world who will tell you how to program and say the right way to program is this, the right way to program is that, right? The thing about programming on Twitch is you have to put your money where your mouth is, right? Like, you're sitting there, you're doing things, either things get done or they don't, and people can see it in real time, right? They can see how long it takes you to do things and whether you proceed toward a goal and stuff. And I think that's why not very many people program on Twitch, because they don't feel comfortable with other people seeing what they do. Especially not people who have taken it upon themselves to tell you how to program. And I think that's suspicious, right? Like, in the same way that you're supposed to be able to see the tax returns of the president or whatever, which I guess is not a thing anymore, but used to be. Like, you know, if you're going to tell millions of people how to program, I think you ought to demonstrate it. You'll communicate much more effectively if you demonstrate how you program rather than saying some things. Anyway, the whole point is not very many people do that, which is why I don't, you know, like if there were thousands of people programming on Twitch at any time, maybe there would be a programming category, but there isn't, because there's like 10 people actually programming at any given time on Twitch. There's more than that who say they're programming, but they're actually like configuring their IDE or reading documentation or trying to figure out how to start or something, right? So, yeah. You code on a 43-inch 4K monitor and you can't stream at that resolution. I stream on a 4K monitor. It gets downsampled at 1080p, but my monitor is 4K, so that sounds like an excuse to me, bro. We'll do the codec stream soon. I know everybody's looking for, not everybody, but many people are looking forward to that. We'll do it soon. It's just today I have a less amount of time because I'm going to work in a little bit. So it's probably not enough time right now to do the codec stream, the first codec stream. It'll be multiple streams. And look at all these things. I haven't updated this in a long time. I hope it compiles. Hey, source code. See, this is the part that Git is designed to handle. This like 30 files out of all of this. Out of the 4,000 files, wait, 7,000 files, 8,000 files, Git is designed for like 30 of them. So, yeah. Anyway. Let's see if it compiles. Hey, let's see if it runs. We may have to compress some textures and stuff. Nobody could read the text. You had to enlarge the code. Yeah. Well, that's fine. Yeah, codec streams will go on YouTube when we do them. That is definitely what will happen. Okay, so we appear to be working just fine. Okay. So today I'm just gonna, my main priority is to hunt down and fix a bug that happens very rarely. And I'll tell you for a minute what it is. Excuse me. It breaks. So, you know, we have automated tests that run every time you check in the compiler or the game, you know, different set of tests for each. And the tests break on rare occasions, very rare at this point. It's like probably like 1 in 300 times or something. And it breaks. Okay. I'll tell you what the thing is that causes the breakage. So we have this thing called the concatenator. Wow, I can't talk today. Got too many files. Okay, it's just a data structure. Breathe, breathe. Okay. Okay, we'll see if I can talk effectively today. I don't know what's going on. Anyway, we have this thing called the concatenator. It's just a buffer, right, where you put bytes in and it's got buckets, and when you fill up a bucket, it allocates a new bucket. And the point of that, you know, is that you aren't reallocating all the time, and you aren't doing this naive string growing thing. You don't have to recopy all your old data if you add new data, right? So that's all fine. But the standard add, we say, hey, if the space left is less than the length of what we're adding, then expand, right? And just having a function and having these extra checks and stuff, it really does make you slower when you're doing a lot of really small operations. It's like a very significant overhead. And the compiler, this part of the compiler, which is the machine code outputter, got faster when we did this thing where we say, we're going to call this thing called add unchecked, which just assumes there's enough space in the buffer, right? So we assert that there's enough space. This compiles to nothing in debug, right? Or in release build. And then we just do this. And this probably isn't even as fast as we could do. Could probably do something better if we just did a machine language thing. But it's faster than doing the if statement. Sorry, I think I was clicking on like this or something before. But the point is, this is the part that's slow, is having this if statement and calling to expand and whatever, right? OK. So we do these things where we don't check the buffer size, right? So here's a version that does check. Here's a version that doesn't check. It's clicking on the wrong things. OK, but you might suspect that because we're not checking the buffer size, we might introduce a bug. It's more error prone. And this is very common. Like when you optimize something, it makes it more complicated and it makes it a little more error prone, which is unfortunate, but that's how it is. So now what we do is at the top of this loop here, we say, this output is the concatenator. We say ensure space, however much, this is just some variable that we can tune, right? This pre-allocates the buffer, and then in theory, nobody in this procedure has to worry about the buffer size as long as at compile time, we make this reserve, frickin' Emacs, dude. We make this reserve big enough in advance, right? So far, so good. Now, the problem is if this is wrong, OK, and if it was only this function that did this, it would be easy to debug. But there's a few different places that do this. And, well, what happens if you get this wrong? What happens if this isn't big enough and there's some path through this function that could pack more bytes than you're reserving here? Well, most of the time, nothing bad will happen. Because most of the time, because it's this bucketed storage system, you'll actually have more bytes available than you pre-reserved. Because this only matters if you were going to have gone over the edge of the bucket, and the bucket is like 64K or whatever, right? So the only time this will ever exhibit is if you try to pack too many bytes and you happen to be at the very edge of a buffer, right? So that does happen on rare occasions. And so what I'm going to do is just make a debug build version of this that, like here, we're asserting that the space left is greater than or equal to how much we're packing. Space left is just how much time is there between the cursor and the end of the buffer, or how much space is there between the cursor and the end of the buffer. So what we're going to do is augment this and say if we're building a debug version of the compiler, then we keep a counter of how much is ensured, which is going to be strictly less than how much actual buffer is available. And when you call these unchecked functions, we're going to assert something about, so it's not going to be exactly what I'm saying, but when we call the unchecked functions, we're going to assert that the amount that's ensured is greater than or equal to what we're trying to pack, and then we're going to decrease that. And that'll be inside an if-def so that it only happens in debug. We'll probably make a macro for it so that we don't have to paste the same code 8 times. The reason why I'm saying it won't be quite as simple as what I just said is that people might also call the checked pack. So like, and that'll eat space. So what we really want to do is when we ensure space, we want to save the pointer to the end of the ensured space and assert that you are within that if it's a debug compiler. And then after we've done that, then if you violate this invariant, it should tell you at runtime 100% of the time, because it won't rely on hitting the edge of the buffer. It'll just be like, oh, you exhausted this resource that you declared, right? And then at runtime, it'll compile out to nothing, right? So we're adding extra checks to make sure an invariant is maintained. Now that still doesn't mean that we would catch it 100% of the time, because it is possible that whatever is causing this not only depends on being close to the edge of the buffer, but also depends on general code coverage issues. Like maybe there's some branch of the code that only gets exercised very, very rarely, and that's also the one that causes the problem. So yeah, but we're going to hope that that's not true. And we're going to do this. Yeah. Are there any questions about what I just said before we dive in and do this? I never remember. We're going to have to put stuff in if debug, and I never remember. I think it's underscore debug in Windows. Yeah. So we're going to say like if underscore debug and add some stuff. The terrible thing about C++ is if you get this wrong, you won't know. It'll just evaluate to 0, which is stupid. So did I actually measure how much overhead is the checking? Yes, I did, because I would have taken it out otherwise, or I would have taken out this optimization. It was significant. It was like, it was around 20 to 25% of the time spent in this code, because we just call this over and over. Like these move 64 indirects, for example, expand to calling this 1 or 2 or 3 times, calling one of these 1 or 2 or 3 times. Yeah. So I think we're going to replace these for readability of the code. We're going to replace these assert space lefts with some macro that's defined one way or the other, depending on whether we're in debug or not. If we're in non-debug, it'll just be assert space left, and if we are in debug, it'll do more things. So in a debug build of the compiler, when the bug happens, the asserts in the unchecked versions are tripping. No, yes, actually yes. So these asserts, one of these asserts is going off generally, right? But it's very rare for it to go off because this space left is just checking against the edge of the buffer, right? Okay. So we're going to start by replacing these. So for all these unchecked versions, for checked versions, they don't do this. But for all the unchecked versions, we'll say debug check space 8, right? Debug check space 4. If anyone has any more questions, please ask them. This is just going to be just a little bit of just dumb replacement here. I probably could write an Emacs macro to do this, but it would take me longer to figure out how to do that correctly than it does just to do this. And my quality of life is actually higher if I just do this. Okay. Okay. So space left. I'm just checking to see that we don't, yeah, okay. So we're just going to say define debug check space n assert space left last. Last is just some variable, you know, defined in this guy, and this macro is only going to be used inside those, so we just use that. We assert that the space left is greater than or equal to n, right? That's all. We don't put a semicolon because they'll put a semicolon. So in theory, oh, we're making a release build right now. That won't even have asserts, so let's make debug build. Is there any way you can hint the branch predictor of the CPU to recover some of the performance? Some compilers have a likely attribute you can put on if statement to hint, which is the most likely branch to be taken. I mean, you could definitely do that. It does seem very compiler specific, and I don't know how well it works. Yeah, you could do that though. And if that was approximately as fast as not doing the checks, then I think that would be well worth doing, because you don't have this extra question about whether it's incorrect, right? However, you know, the branch time is not the only problem. I think code size is a problem, because this is inlined all over the place, over and over and over and over again. And I think the code just gets a lot bigger, and that's bad for instruction cache. I mean, I haven't measured that, right? But in theory, like, we just call this over and over and over and over and over and over and over many times in one procedure. One big procedure that we switch into a piece of and then switch into a different piece of, and yeah. But that would be an interesting experiment, right? I'm not going to do that right now, because my goal right now is just to fix this bug. But that would be, if that could be done and the performance in the end was the same or close to the same as this version, then that would be preferred. But yeah, I'm not actually sure. I don't even know how you would actually tell an x64 CPU that a branch is likely one way or another. Like, I mean, I see how you would do that a little bit as a code generation hint, but I'm not sure that x64 has that. I don't know it that well, though. It might. I know some other chips have that. Is the size bounded at compile time, or can the user hit this bug if they are compiling long files? The size is bounded at compile time. The problem is we don't know the size. It would require some kind of static analysis on the code to figure out the size, and C++ is not good at that. If we were writing this in our own language, we might be able to statically analyze that, you know, as long as none of these were called inside loops of non-fixed size or something. Like, we would be able to do that. But C++, you just can't do that. That would be an interesting, I should put that somewhere on my list of, like, someday when we rewrite things, do that. Well, thank you. I hope you all have a great day. We will have a good start at a great day if we fix this bug. Okay, so we're going to make a debug build of the compiler, which actually has the asserts in it. And just as a test, we're going to compile the Sokoban game, which takes like 30 seconds with a debug compiler. Another thing I want to do, probably not during this stream, is figure out what's taking all the time in the debug compiler, because there's probably a small number of debug checks that are taking the majority of the time. Wait, how is it only 4 seconds? I thought it would be longer. Is it because it's the x64 backend? Or did we take out something egregious? Okay, the LLVM backend seems to be much slower in debug. Much slower. Much, much slower. Much, much, much slower. Are we using any sort of multi-threading? Yes. Burst compiling? Burst compiling is something that Unity made up, as far as I know. We use blast processing like Sonic. Like, why do people take something that one company did and pretend like that's like a thing now? I don't know. Sorry, I shouldn't get that annoyed about that. But yeah, we've multi-threaded portions of the compiler, the parts that were easier to multi-thread. Parsing the files is multi-threaded, and actually the LLVM backend code generation is somewhat multi-threaded. Still slower than the x64 backend, but yeah. The thing is, there are some parts that are a lot harder to multi-thread than that. Like the parts that take the most time right now are also the hardest to multi-thread. Over time, I'm trying to re-architect the compiler to make it more feasible, but it may be a while, honestly. How are you able to build the whole Sokoban game in one invocation without running out of RAM? When in your project you have specific C++ files that take several gigs of RAM to compile each. You're going to have to ask Microsoft why it takes several gigs of RAM to compile a C++ file. Why should it? What should your compiler be doing that would possibly take that much memory? It may also be related to why your compiler is slow. The Bitcoin miner hidden in the compiler. Yeah, maybe. Okay. I mean, we have so much memory. I used to compile C++ programs on a computer that had 8 megabytes of RAM. Okay? Like, why can't you compile C++ today on a computer with 1,000 times as much memory as what we used to? The same program, well, kind of the same programming language. It's gotten a lot more complicated since then. But like what is even going on? It's insane. It's insane. I actually know what's going on. I've kind of figured it out, sort of. I'm going to do a speech sometime about why software is slow. I just need to do further research to like back it up very. But like, just, yeah, the one thing I wish people would do is like actually look at the raw numbers of how much slower software is today than comparable software that used to do basically the same thing. It's completely insane. It's, 3 orders of magnitude plus. It doesn't make any sense. Like, it's frickin' bananas. Do I think software should follow the Unix philosophy more? No. I think Unix philosophy has led to a great deal of complication. I don't understand why people think that that's a thing. Like, look, the Unix philosophy was great in 1970 when the jobs we were doing were of a certain size and when operating systems were at a certain very early stage. You should have a better idea than that 50 years later. If you don't have a better idea, like, computers only really started being a thing in the late 1950s, okay? So the Unix philosophy was developed, let's say, 15 years. Well, you could go back. It depends on how far back you trace things, but like 15 years into something like the history of modern computing, all right? We're 3 times, I don't know if it's worth thinking about linearly like that, but we're several times further away from the Unix philosophy than the Unix philosophy was from the beginning of that kind of computers at all, period, right? We should have better ideas by now. The fact that we don't is a damning condemnation on the state of things. Is it because they persist multiple complete asked views in memory? No, because I do that too. And my compiler doesn't take that much memory. Like, syntax trees, the size of them is proportional to the size of the input text, right? Like, if you have some text that says, here's a declaration. It's got a left-hand side and a right-hand side. You have a node for this and a node for this. Those nodes may be bigger than the text, but they're a constant factor bigger than the text. Probably. So it probably takes more memory to represent your syntax tree than characters in the source code, but not that much more. It's not like n squared. It can't be n squared. That doesn't make any sense. So I'm just saying. You think I conflate my justified hatred of dynamic libraries with the Unix philosophy, which I think is unjustified. No, I'm not. Dude, dynamic libraries didn't happen until way later. Like, don't forget, I went to college in 1989, okay? We didn't have dynamic libraries in 1989. We had plenty of Unix. We didn't have dynamic libraries. So it's like, it's a very younger programmer thing to assume that I'm conflating those two things. I'm totally not, okay? I think the Unix philosophy was good for 1970. I don't know how much more I can say that. Like, how much more plainly can I say that? It was an idea that made sense and was probably a significant improvement on the alternatives when it was devised. Before any of us watching this stream were born, probably. Certainly before me, and I'm older than most people watching this stream, okay? But then you have template expansion or whatever alternate mechanism the language provides for code generation. This language has template expansion too. We don't have that problem. I don't know how much more clearly I could say that either. Stop making excuses for your shitty compiler or Microsoft's shitty compiler. It's not your fault. All right. Yeah, so this, let's verify that what we compiled actually run. We haven't done any work. We're 30 minutes into the stream. All right. So let's do this thing. So here's what I'm going to go. I'm going to go if underscore debug define this as this following very sophisticated thing, else this. And the reason I'm doing that is because this is frickin' C++, and if you get that wrong, you'll go crazy. So I'm checking that this is actually happening in debug and not happening in release, which, like, okay, it worked, but those of you who have done a lot of C++ know that that was not a given. All right. Yeah. Okay, so now we do the real thing. What is it? Well, we're going to have, let's leave this for a second. We're going to have some member on the concatenator called so now we're going to have a pointer. Let's go to string bucket. So this has char stars to point to all the things. We're going to have a char star last ensured, end of ensured space. Okay. Now, however, if you called ensure space when we're, so the way we would check this is just say, hey, ensure that between the current point, it's called, that's where the next data will go. Between and that, this and that, there's enough ensured space. But what happens if you called ensure space on a different bucket? And that bucket happens to be later in memory, then that would be a bug that you wouldn't catch here. So I'm also going to store start of bucket that was current when we ensured space, right? So what our macro is going to do is first it's going to assert that this is equal to the start of the current bucket, right? It's going to make sure we're in the right bucket, and then it's going to assert that the amount of space is there, right? Okay. So let's set those. Let's actually, here's what we're going to do. We're just going to have this be the same for right now. We're not going to check anything additional yet, but we are going to set these things. So ensure space we're going to say this is last arrow start. We're going to say end of insured space is point plus last arrow point plus num bytes. All right. And we're going to do that down here. And again, because it's C++ and we can't trust hash if, let's make sure that those happen. Yeah. All right. Like, I wish it weren't so, but it is so. Okay. So now we check these things. Here we say, we're just going to make a block. Assert last arrow start is equal to this giant variable name. Also, if we forget to put a backslash on the end of any of these lines, we're hosed because it's C++. We assert that. Of course, we're not hosed that bad because that'll just be a parse error or something. Assert end of insured space minus last point is greater than or equal to n. Let's put n in parentheses because it's a macro substitution. These are all the things that you just learn to do so that you don't get surprised. Like this is because if this is something complex and it gets substituted in here as text, the operator precedence could cause bad things to happen. Okay, something like that. I actually don't remember because we'll get a semicolon inserted at the end of this because we set it with a semicolon. So I think that works though. I think that's valid. Okay, well, either I got this right or I got it wrong. Hey, well, okay, so this assertion went off. Either it's because we messed it up, or it's because we found our problem. I suspect we found our problem, but I'm not sure. Let's check. It's my opinion on the Odin programming language. I honestly don't know enough about it to say anything. You could define a real function in underscore debug and define an empty function like macro and release, guaranteeing you'll get your stuff evaluated like normal C++ code. That is true. Oh, wait, did I not? We have to make sure it's x64 build, because that's what has this code in it, is the x64 backend. Yeah, I'm just worried about speed of debug build. Okay. Well, are we? I actually don't know. Like, are we in the middle of this loop or not? I don't have a way to know. If it's the first time, then that would be suspicious. Okay, let's see. let's see a concatenator. Okay, the start of bucket that was current when we insured space is null, which means we just didn't insure space, or we screwed it up. Okay. So these are all unchecked. See, this is what I'm saying about like doing it over and over. I later made versions, you know, when we went and edited this, I later made versions where you pass multiple bytes. These are all 1 byte at a time, but you could say like 4 separate bytes. And we could convert this code to use that. Maybe we will if we have time. Because that would be nicer. Let me see if someone does that. No, just the other file does that. So that would be nicer. But we need to ensure space here. Let's look at, I want to look at this in an editor that I'm used to. Emit code for function declaration. Okay, so what happened is this guard page, no? Okay. This one was added by me. This one's my fault, and this is someone else's fault because somebody else added that. But the problem here is, you know, we're outputting instructions. All those instructions use unchecked things. And so the caller has to do a check. And this probably does a check. Maybe not. Maybe we have just tons of these problems. Here we're ensuring space. Here we're ensuring space. Here we're not. So like, we might have, because we've never checked for this in this series of a way, we may have several different problems. All right, so we need to and it doesn't matter what we say here. Like, we try not to bloat the buffer, but if these numbers are big, it doesn't matter because the most that you can waste is this many bytes minus 1, at the very end of the program, and that doesn't go into the program. It's just like RAM that you're using to generate, right? So like, I don't know why I'm making these so small, honestly. Oh, wait. No, that's not true what I said, because the thing is, if the buffer, we'll skip to the next buffer if the space left in the current buffer is less than this. So we actually don't want this to be that big, or our buffers are less efficient. Sorry, I said the wrong thing. So you know, we're just gonna guess. Like again, we should be, if we had advanced software technology, we would do static analysis to determine these values. Unfortunately, we don't have advanced technology. We have C++. So we can't do that without programming all this in some like meta language that gets compiled to C++, and that's just always a disaster. So we're not doing that either. Okay. All right, we're going to go down to the place where we actually like that. So that'll fix that one. I think it's likely there are other ones. Because what happened was, when this code was originally written, everything was checked and everything would automatically make space. And then at some point later, I went and optimized it. And I should have done a very serious, why do I live in a loud place? Why do I live in San Francisco? I don't understand. Okay, so here we're actually in the middle of, well, I don't know. Yeah, we're in the middle of stuff and we ran out of space. I don't understand why. So output machine code here at the top, sorry, we're here. It has an ensured space of 64 bytes. And apparently, this one uses more than 64 bytes. Which I don't understand. Like, what? Like, does this, I don't think that, yeah, that just makes a place. I am not sure why this is happening. I mean, here's a move. Here's a move. Oh, I can delete this. This is this old concatenator debug thing. Like last time I tried to debug this, I did something that wasn't as serious. So I'll write that down. Delete concatenator debug and use that bytes versions. Okay. Well, this is kind of a mystery because, well, I mean, this is like 32 of 64. So we say ensure space of 64 at the top, and then we get down here and we've somehow used 64? Or there's a bug in our tracking. So let's just check. Let's just check the things. Sorry, output. So we did set these pointers correctly. And last point, output last point. Oh, God, it's fucking C++, dude. So we're like literally out of space with 0 bytes left, which makes sense because we were calling a 1 byte add. So this move 64 indirect. Let's look at this. If the size is, I mean, it's 4 bytes. Oh, potentially 8 bytes if we do this. If we're in, yeah. Because we do a 4-byte instruction and then a data part down here. So by my cursory visual inspection, this should just be 8 bytes unless this is something bananas. This has its own oh. Okay, here's the bug. It's not really a bug. Here we're calling an ensure space that is smaller than the one that we ensured above. So actually more space is ensured than what is actually ensured. And we need to allow, our tracking needs to allow that. That's what's going on. So it gets more okay, let's delete this concatenator debug because that's old. It was a much less effectual way of doing this, and it involves sprinkling these manual checks all over, and that was not, it was not the play. Our current version is working much better, right? So sometimes you do a better job the more experience you have. All right. So we just saved some lines of code right there. Cross that off our paper list. I'm just making sure also that the compiler still compiles. Okay, so right. We need to go here. Oh boy. Here we're going to say, going to get rid of the cut and paste. We're going to say set debug info. We need a better name than that. Set debug check space info. Because we're going to make it more complicated, and as it gets more complicated, it's really less of a good idea to paste it. So in release build, this will become nothing. And here it'll be, I deleted the code out of my buffer. And that's not an assert, that's just an assignment. And we're going to say, what is going on, dude? So end of insured space equals last point plus n. Okay. Oh, also the great thing about C++ is if there's an invisible space at the end of any of these, then you're hosed. Oh, plus n, right. Right. So now, if we run, we're still going to get the same assert. I'm just making sure that it compiles and stuff, because we haven't fixed that problem, which is that we're ensuring more space and then ensuring less space later. So we're going to say if these are equal, we can't really do a comment in the middle, can we? Damn, dude. I guess we could do C-style comments, whatever. If we ensured a larger space, don't stomp on that if we ensure a smaller space later. Sigh. Okay, so if, why is it not, oh, wait, what? Just, indentation is not working. Revisit the file. Still doesn't work. I might have a syntax mistake. Sometimes dude, I don't know. I just give up. Missing backspace on the right, but whatever I type here is before. What? Okay, that doesn't make any sense. All right, whatever. That's just whoever programmed this was on drugs. Because it's part of the macro until the backslash. So it should be indented. Until the backslash or not backslash. Like whatever's on this line is part of the macro. And it shouldn't, yeah, whatever. Okay. So if they're equal, if I'm explaining why. Okay, if I can't say return because it's not a function. I'm going to have to make it a function in order to not go insane. All right. This comma n, right? We'll put the n in parentheses just to be super safe. Okay. So we do that. We do that. Okay, so now we have the problem that this is up at the top of the file. Because we're in C++. We can't do that. It's exactly why I work so hard, because this is a waste of everybody's time to do these things. It's why I work so hard on this language, to make you not need to do that. And it's hard. Why does C++ do that? Because it has to parse and handle things as a single pass from top to bottom of the file. So you cannot use any identifier that is not declared earlier in the file. That's how it works. We may still get an assert now, but it looks like a different one. It is. So we may have made progress. Okay. So So this is before we get to the actual argument. See, this is the stupid ass thing about Visual Studio now. We're actually in here, but it's pointing at this. This is not relevant. We're in here. Like, this used to work like more than 10 years ago. This was all fine, and then Microsoft rewrote this program and broke everything. We're in here, and they will do that. It's true. They were like, we're going to rewrite it from C++ to C#, and it's going to make everything better. Didn't make everything better. It really didn't. When are people going to learn? Okay. So the caller, I mean, so this is also packing stuff, right? So before we call copy arguments inward, like we could, since this is sort of its own thing, we can put an ensure space here as well. So that we don't have, because otherwise we would have to say like, well, whatever much we're ensuring for the parent function also has to cover whatever happens in the child function. And that's a little bit maybe harder to see as a programmer. So I'm just going to do this. So if it's a C callback, we do whatever. Although there's really only one move here, so we could probably go less than 32, but whatever. In this case, I mean, it's really just 8, I guess. We could probably cut it down to 16 just to, let's see if we don't hit that one anymore. Yep, we're in a different place. Totally different place. Yeah, like I said, there's a number of problems. But we're back in for function declaration. This might be for arguments to the function, though. It might be a different spot. Let's try 16 here. I think 16 is fine. Yeah, so now we move on to the next one. All right, add U4B unchecked. We're back in function declaration. Oh, it's this. Okay, now I'm confused because we said 32 bytes. I suspect our checking checker might not be right. Because look, here we just ensured 32 bytes. We call sub 64 immediate, which I don't think is... This is 7 bytes at most, right? So we can call it 8 just to do that. And then I think we said this is 8 bytes at most. These don't add anything. Those are just setting variables. 3 or 4 or 3 or 4, and then maybe another 4. So I don't understand if our checking is correct. I think I goofed. But then this doesn't call ensure space, and this doesn't call ensure space. Oh, this is a while loop. Ha ha. Okay, why are we in hex? Okay. Why? Okay. So this is like, this is a procedure with a lot of stack. And we just keep emitting stack check instructions. We don't output a loop into the procedure. We just say, oh, let's emit one instruction per 4K. And yeah. Let's make that 16. That's fine. And this is slow because all this is doing is essentially putting back that check per instruction that I said. Actually, it used to be like 4 per instruction or 5 per instruction, but it's putting back 1 per instruction that we emit. But this is a very rare case for most programs. So, and it's, even if it's not that rare, it's a minority of the instructions that we would output for the program. So I'm not worried about putting that check back in that case. Hey, we compiled. That's good. Let's try some other programs. Oh, we need to be in x64. Oh, here's one of the frustrations of working on stuff. So part of the whole thesis of this system that we're trying to build is to get rid of this kind of bullshit where you try to run something and it can't run because like DLLs are not installed in your system. But people have added test programs that link against C libraries that have DLL dependencies. And now I can't run tests unless I frickin' manually copy. That's not acceptable. I'm going to bug people about this again today. This is not okay. I worked around it while I was traveling. But this is bullshit. You're not allowed to do this. I mean, maybe I should just finish the new library code and try to handle this, but I'm not 100% sure that the problem will go away. We'll see. But yeah, this is the problem, right? Like you can't, it's very hard to fix things because people will keep infecting them with like legacy stuff that is infected. So I don't know, man. It's hard. It's hard. For this, there's not really any excuse because it shouldn't be linked against the dynamic link library. Like, that's just not a thing that should happen. So it's just something that somebody manually did that's breaking things. Like, I'm going to work around it right now, but this is bullshit. Like, it's not acceptable. All right. I'm just going to copy those. What was the other one? SDL2. All right. Okay. Now we could actually run our program that we want to run. It's taking a long time, I guess, because debug compiler. Why is it LLVM backend? Okay, hold on. This is not testing what we wanted it to test. Frickin', what did we just run? See, I thought the test program was supposed to. I don't know how to run these tests on the x64 backend. I don't see the string x64 in this entire file. This is the frustrating part. Like, this is one of those things. So this is it's partially just a multiple programmer problem. Like, I didn't write this, so I don't know how it works. And it's not telling me how to do this thing that it's supposed to do, which may mean that it does it and I just don't know how to do it. And it may mean that it just doesn't do it. So I need to figure out, I need to just edit it, I guess. It's saying backend : right? Which means it's got a provision for that. I don't even know where that code, it's like compiling something else. It's like, it's not this program, it's another program. Like, I just don't even know what's going on. All right. Really? It's printing backend : Okay. That is here, tests, language tests. The colon or the quote might have confused the search here. Let's just go backend : Yeah, there we go. Okay. This is like, yeah, it's a program running other sub-programs. It says controlled with command line arguments. -x64, but that's... Oh, do I do this? No. I think this sub-program takes that, but the other one does. I don't know. Here's how we fix this. And that means the other tests aren't going to be x64. Okay, hold on. Let's go back to this. How do I just pass command line arguments to the subprograms? I don't see a thing. All right, we're just going to run it on the standard tests. Whoops, that we just did. And we're going to have a team discussion about how to fix this. Let's do this just in case. Okay, well, we're actually running these through our assertion checks. Test executable also takes command line arguments. I know, but it's like... All right, so I'm happy that all these are passing with our new assertions. I might have still made a bug in the assertions. Hoping I didn't, because it certainly caught several instances of that problem. So I'm confused about this because the thing that I edited to put was this, right? Which was just in language tests main, but I guess that's getting compiled into all of these, even though it's just in the... Because like this is language tests. It's like one thing in examples, but it says x64 for all of them. I literally don't know what's happening here, but I'm hoping that it's good. So now I think we compile a release build. We make sure that still works because it's always possible that we added a syntax error. Too many actual parameters. Remember, I defined this without any parameters at first, and then we added n, and I forgot to do that. Where was that? Concatenator.h here. Maybe somebody caught it in the chat and I didn't see, but we need that. It doesn't actually matter. That should be an error if C++ macros were reasonable, but they're not. So it's a warning. Should be an error. Yeah, so then release build still works, still runs, and then we get to declare success. And then I get to actually go to work and do my work job at work. This is part of my work job. I just get to go to the office. Any questions about what we did today? Test.exe-x64, you're saying. So let's first of all verify. So I changed it back to LLVM. So let's first of all verify that that worked, right? So we're just going to run test.exe. Yeah, it's defaulting to LLVM now. OK. So does it say that? Oh, OK. It says right here. The problem is, this is one of those things that seems to make sense when you document it, because you don't know what the other person doesn't know. Like, I don't know what passes args automatically means in terms of what I want to do, right? Like, what I want to do is use the x64 backend, and the string x64 does not exist in this file, right? And so what needs to be added is another example here, like, here's how you run with the x64 backend. And then I would know to search for that, and there could be a comment there that says, this works just by, yeah, in fact, I'll add that. Oh, this actually says, I didn't see that in the source code search. All right. All right, so we're going to say to run with the x64 backend. -x64. This works because test.exe just passes the x64 on to the compiler in each individual case. This is covered in test.exe-help. So part of the problem here is, and again, this is like, it seems reasonable to say, hey, test.exe has this stuff. But like, I don't know, it's like, as someone trying to make this do what I want it to do, I don't even know what that means, right? And then if I'm trying to search for something I care about, I could search here, but I can't search this because that's like text that comes out in a different place as part of a program invocation. So we'll see if this approach scales of specifically mentioning things that I care about for later use. Okay. Yeah, and it's not, this is one of these things where it's actually a hard problem. Like it's like when you're writing documentation, you have to try really hard to see things from the point of view of somebody who doesn't understand the thing. And that's a hard thing for human beings to do generally. It's a skill that we can build and get better at, but it's very easy to make mistakes. It's actually also when you design video games, game design is a lot of the time about figuring out how your game looks from the perspective of somebody who, doesn't know anything about it. Because you're making an experience for that person who starts your game not knowing what it's about. So it's very similar in some respects. All right, so I'm going to check this in. And actually, we're not going to end the stream quite yet because fix spurious, what was it called? Space left assertions. And add some documentation to there. All right. And I don't even know why that's modified. Okay. Now what? Oh, yeah. Have I watched E3? I have watched the major presentations so far, yes. Elden Ring, it's like, the problem with that is that, like most E3 right now, they're just not showing gameplay at all. They're just showing CGI movies, and like, these CGI movies are not movies that anybody would see for their own sake. They're just to announce a game. So they're like not good movies. So why am I sitting there watching CGI movies? It just feels really dumb. Like, you've got to put some gameplay in there, or else I don't know anything about your thing, So it's a pretty bad E3 so far. Not just because of that. Like some of these presentations, I won't say which, but I was watching a presentation yesterday and I just felt like I was in the middle of a bad drug trip. I was like, what is going on? The things that they're saying don't make any sense. Like repeatedly, and everything feels like it lacks direction. And then all these trailers are just like, the trailers aren't even trying to do a good job of introducing a game and telling you what it's about. They're just like, this is a game with a very expensive trailer with like a bunch of sci-fi shit in it, right? Or this is a game with a very expensive trailer with a bunch of fantasy shit in it. And I was like, what is going on? It didn't make any sense. So, somebody's mentioning the 120 FPS thing. Yeah. Yeah, no human being has ever seen 120 FPS in their life. Certainly, PC gamers have not been doing 120 FPS or 144 FPS or 240 FPS for years. Certainly nobody knows anything about that. Yeah, that was a weird one. But like, I don't mean to single that out too much because all of E3 so far, not all of it, but most of it has been approximately that bananas in terms of like, why is somebody on stage saying this thing? Like, I don't get it. I just don't get it. And that is not even necessarily anything that new because every E3 has some degree of that. but it's like 100% that this year. Not 100%, but close to 100%. Yeah. All right. So let's go to is it here? Yeah. So here, when we started doing these atomics and all this, I made this shorthand that's just like pass the bytes in, right? Individually, and it's as if you did a bunch of these calls. And I didn't want to go retrofit these because like it's possible to make mistakes. But we're going to do that now. And it'll make the code shorter. And we're going to do it a couple steps at a time. You know, I mean, we'll do just this one initially. All right. So see, that's just shorter. Okay, wait, I obviously made a mistake. This is 4 bytes. See, it's very easy to screw up. And again, it's C++, so like casts or warnings, which is not great. Let's just double check what we just did. Okay, so this was 4 bytes. This was 3 bytes and then 4. And because these look similar, I just straight up deleted it and whatever. So here we're going to do the 3 bytes and then with there. All right. All right. So let's check that and make sure the game still builds. So when it comes to FPS, definitely seeing a difference or not is nice, but it's beyond what you can see, right? Like the latency with which your input is handled decreases as your FPS goes up. All right, that's actually one of the most important things. Like if you talk about the feedback loop between you seeing something on the screen, pushing a control to react to it, and that control being processed by the game and then affecting the game simulation. That, of course, there's always a human reaction time element there, but then there's padding that goes on to that reaction time that is proportional to the frame rate and other highly questionable things. So like, if the game does like multi-threaded rendering in order to try to compensate for otherwise low frame rate, then you can add more latency in that process. And so even if you would say like, oh, I can't really see the difference between 60 and 120, your latencies are cut in half, your added latencies. Okay. So that appears to have worked. Let's do some more. We might not do all these tonight. In fact, I'm going to do a few at a time and then check in, because it's always possible to screw these up. And this is all going to have to get much more complicated later, because like we're not doing any instruction selection here to speak of. So each of these functions might get more complicated, or the caller might be more complicated in terms of deciding what happens. Okay, we're actually not fixing a bug anymore. So I'm going to change the title of the stream. Compiler cleanup time. That is what we're doing. We're cleaning it up. All right. All right. Let's run one of these. I mean, I guess they do run in test mode or something, because I know the language tests do. But let's oh, the ghosts are drawing their movement direction now. That wasn't true last time I played. All right. So, Blobman. What process in game development do you find most fulfilling? Is it producing, programming, designing, or the writing? Some combination of programming and design. Producing, I don't enjoy. And writing, I don't do very much of. So, did I ever consider using the AV1 codec? No. You never saw Blobman? It's Blobman, dude. All right. It's not really a cleanup. It's a tidy up. Because it's not like it was messy exactly. It's just like it's getting tidier. Oops. Almost did it. Almost did it again. All right, and okay. Uh-oh. We broke something. We are straight up crashing. Okay, rather than fire up a debugger, this is why I checked in, by the way. We're just going to diff and look for the mistake. Okay, rexw29, 3 up, 2 up, 1. xw28, 3 up, 2 up, 1. xw23, 3 up, 2 up, 1. 8.1, opcode extension. Okay, this is the problem. I pasted, see, when I was doing this, I was like, that's a bad idea, but I'll do it anyway. I pasted this and edited it, and here, these arguments go in the opposite order than here for some reason. And I feel like that shouldn't matter because it's symmetric, but we certainly changed it. That is my candidate for the bug. Let's check the rest of these. Oh, because it's probably and into a target register. Yeah. Okay. Yeah, I think that was the main issue. Do I have air conditioning? Yes. Oh, someone caught it in chat. How does one make a programming language in the first place? Do you have to assign your syntax to machine code like zeros and ones, or is there a middleware that translates for you? Well, there's the LLVM, which I guess you could call a middleware. It's like a library. I don't know what the term middleware is supposed to mean. It's just a marketing term that somebody made up. It's a library that'll do that. Yes. But you essentially have to go to LLVM's zeros and ones in order to do that, and that's a pain in the ass too. So, but it'll at least target multiple platforms once you've done that. What we're testing right now does not use that at all. What we're testing right now, this stuff that we're doing, is just outputting machine code directly, right? So this ran correctly, right? Yes. So since we dodged a bullet there, let's check it again. Okay. So I'm going to leave these, even though it's like 5 bytes, and I could pack it, I'm going to leave it separate instructions. Because what we're doing here is really more about readability. Like, probably the code will compile faster, and it might even run faster because the code generator is less confused by all the procedure calls and whatever. But you know, it impacts understandability to string 2 instructions together like that. So we're not going to do that. Dangerous to type those in manually. Okay. All right, let's test that. Uh-oh, I made a mistake there. That's not... does not raise confidence. Okay. Bada bing, bada bing. So this is really, what I'm doing right now is really just a very relatively dumb, straightforward elbow grease code maintenance thing. But dude, this stuff really matters in the long term. If you don't do these things, then you just end up having regrets. I mean, for cases like this, I'm not sure if it's really worth it, but just for consistency, we're doing this. All right. Like all these times, these are all going to get more complicated because all these times when we say rex w, that's a constant that says, hey, this is a 64-bit instruction. But if you're going to use the higher, like the added registers in x64, you need to set a bit on this so it's not just rex w. Like this depends on which target register you're using. And then so does this, because you would end up like masking this. Like basically one of the bits of the register index is here and the rest of them are here, which is garbage. But that's the instruction set that we have to deal with. So like all of this is going to get slightly more complicated, unfortunately. But that is just the job that we have to do. Is the macOS guy for the compiler also on Twitch, YouTube? Well, I mean, I think Josh is doing that still, maybe. It's not like most of the compiler is as operating system in specific as we can make it. So it's not like there's a giant body of work involved in running it on Mac. It's like we do the small number of adjustments that you need to run it on Mac. You know what I'm saying? So I'm not sure you would be that excited by seeing that. Let's keep the comment. You know what? 6.6. I wish I could do this, but we can't. It's not an identifier. Call it op 16-bit. Then I don't really need the comment. When these get long like this, then it starts being debatable whether it's that great to pack all these into one call. When it's short and simple, it's like, oh, that's definitely the right thing. And now it's like, but whatever. So here is a case where we're actually checking. So there's there's two registers, and if they're greater than R8, then we set the bit in the rex. So that's what we're doing up here. And so we basically need, it's just being handled very specially in this routine because that's all we needed it for now. But later when we do general register allocation, we need to have something that like in the rest of the program, we want to be sane. So we want to talk about the registers as if they were like linear in number. And then here, when we encode it, we would just have a function or a macro or something that takes these two things and sets the bit in the rex and masks it off of the registers ModRM and SIB must be doing the masking already, right? That looks like a bug to me. That they're not doing that. Oh no, we're masking it right here, never mind. Yeah. I was looking for it down here, but it's up here. Yeah, it's stupid. If you were to design today's modern processors or x64 processors, you wouldn't have any of this crazy things going on in the instruction encoding. So all this code could be simpler, but we can't do that because we can't have nice things. Currently a little bit stuck on how to deal with the blocking notification center. Yeah, I've never dealt with that, so I can't tell you anything. I will say it is definitely the case that all modern operating systems, or at least Windows, Mac OS, and Linux, all of them make just writing a main loop and responding to input events way more complicated than it actually needs to be. They're all just bananas, right? And again, if they hadn't done that, software wouldn't be as messed up as it is today, because everything, I mean, that's like 1 out of 1,000 things, or at least maybe 1 out of 100 things. But like, that one is important because it affects everyone's main loop and they put all this work into it. And if it was more sane, the program would be simpler and people could have spent that effort like dealing with bugs in what the program is actually trying to accomplish rather than dealing with bugs in like input handling. All this stuff matters and we just don't take it seriously enough. And it's just adding up over time and killing us, man. It's not funny. It is not funny. Okay. Did I commit? Where are we at? All right. Dude, it's so loud outside my window today. People are just riding motorcycles around as if that was a good thing to do. But now there's a construction truck. I don't know what's going on. I don't know what's going on. It's insane. It's insane. All right. Rex W. OXOF. OXBE. There. We're halfway through the file. Ugh. Maybe we won't do all of them today. The next amazing E3 presentation starts in 15 minutes. So we might go do that. No, 3. Since these are long, I'm going to leave them. Oops. Let's make sure we actually compile it. Someone's saying OXBE, not OXB3. Wasn't that something that I typoed for a second and messed up? Or... yeah, I must have typoed a 3. Is that the one that you mean? Oh, whoops. Okay. I guess we just didn't exercise that one in a way that crashed the program. Yep, it is possible to make mistakes here. Thanks for catching that one. I really should do this strictly by pasting. Verify that it still works. So let's see if we can blast through the rest of the file in the next 11 minutes. 11 minutes. Okay, let's not make that mistake again. Wait, is this where we were in the file? Let's double check that in a second. We can, in cases that are long like this, we can, whoops. We can just put them on separate lines like this. Okay, did we? Yeah, I think we. Okay, for consistency, I had skipped these before, but for consistency, I'm going to do this. There. All right, like that. It had U1B unchecked. It's a long procedure name. It's like things are a little more comprehensible with a shorter name there. Okay. We're saying paste only. No more typing the number. We got it wrong already a couple times. I'm not sure if this is me having things backwards or x64 having things backwards, but yeah. Wow, man, time flies. Like I was first writing this x64 backend in December 2016. Oh my God. All right. It's so long ago. Okay, we're going to paste the 0. We're not going to type it. Oops. Well, we'll do this in a second. Okay. All right. Bam. Well, it at least appears to work. Let's hope that this works, because we haven't run these in a little bit. So if these crash out, then we're going to have to be in the business of binary searching to figure out which check-in broke them. But it looks like they're working. All right. Okay. 74%. We might do it. Let's just do that. So rep, whatever. So we don't have to comment that that's rep. We rep, we rex w, x84. Okay. I so want to type these. Emacs, help me, Emacs. Nope, we're not typing it. We're not typing it, we're pasting only. All right. Wait, was rep? Rep is OXF3. Yeah, we'll leave that one. That's weird. Like, this is not called rep in the x64 instructions, but it uses the rep prefix. I hadn't noticed before, probably. Dude, Emacs, why is it so hard? We're at 87% of the file. Test that. These work. Great. 89%. Oh my God, we're there. See, it helps to have a great deadline like the PC gaming show to look forward to. All right. Bam, bam. Okay. Well, thanks everybody for coming by. We're going to watch the fabulous PC gaming show. We will do some more streams soon. Many more programming streams are coming up, and we'll be doing more interesting things than search and replaces. Can you rewrite code that would normally cause an error in the compiler message loop? No, you cannot right now. We're thinking about ways of allowing you to do that, like maybe you intercept the message earlier. Or flag a routine to not be type checked. But that may add complications for user code. We'll see. But yeah, right now it doesn't. Oh, it should be x64. Thank you. No, not x643. That processor doesn't exist yet. OXF2 is rep NE. Okay. Why do you use SDL? One of the tests is using SDL. Like we're providing a bunch of libraries that people may want to use for making games and other things, and one of those is SDL, right? So we provide an interface to SDL. The compiler doesn't use it. The game that we're making right now doesn't use it, but some tests and demos use it, and you're free to use it if you would like to. All right. Cool. Thank you, everybody, for coming by. And how do you deploy this software? You run the program. Yeah. See y'all later. Feels good to be doing a programming stream, not from a hotel. So you're not relying on it? No, of course not. Of course not. Bye, everybody.